Alright, so we're going to do this Forces and Motion Basics simulation from the University of Colorado. They have these FETs that allow us to run some simulations so that we don't have to do the experiments live and in person. So this one is called Forces and Motions Basics. What we're going to do is run it in HTML5 here on my computer because it works so easily. The simulation will load. There's a number of different things we can do with this simulation. We're just going to go really basic for right now to talk a little bit about forces in motion. So we'll go to the Motion tab here and take a look at what's going on. So we have a crate. If I click on masses, I'll see that it's a 50 kilogram crate, and if I click on speed, I get a little speedometer up here. I could replace the crate with a refrigerator if I wanted something a little heavier, or you know what the heck, I could stick some dude or kid holding a trash can, whatever I wanted to do this simulation. For right now, we're going pretty simple. We'll do a 50 kilogram crate. And there's different ways that I can apply a force here. I can have my robot thing push, and then when I stop pushing, it stops pushing, and I can have it push backwards, and when I stop pushing, it stops pushing. We're in a situation where there's no friction, so I push for a while, and it will move. If I get this moving and it's bothering me that it's moving and I want it to stop, then I can just reset. The reset button is here. I'll go back to showing the masses and the speed. I can look at the values for the force if I want to. Now here, applied force, 0 newtons. What I can do is push to get a constant 50 newtons of applied force. So this person, my robot model here, is pushing with a constant force of 50 newtons, and that's being applied to my 50 kilogram crate. We'll talk about forces and values for this later, but for right now I'll let you know the secret that a force of 50 newtons applied to a 50 kilogram crate is going to give us a constant acceleration of 1 meter per second squared. Now apparently our robot person can only run so fast, so as the velocity keeps increasing on our crate, eventually they can't go any faster and they fall down, and the crate will keep going at a constant velocity, whatever that value is. So your assignment in this lab is to explore the timing of that, to explore what's going on with the velocity and the acceleration of this crate. Almost always for a constant acceleration of 1 meter per second squared, but in some of the problem exercises will vary the acceleration, will vary the time, and you'll have some calculations to do. I'm also asking you some questions about graphs of position versus time, velocity versus time, and acceleration versus time. You can read up on those concepts in the chapter if they're unclear to you, but there's no graphs on this video for you to look at, so you'll have to get that information from elsewhere. Have fun!